So if we go back to our original diagram, right, this is what is going on. We have high side injection. Now the IF tunes it. And then we get into our next stage, which is the detector stage. Okay, so all that happens here in the IF stage is he amplifies it at this tuned frequency and then injects it into the detector. Now, some things to note, notice the AGC line. Okay, now AGC is taken from the detector phase. Okay, so again, what happens in the detector is very much like we saw before. It's basically clips the top portion of the diode, and then what we try to do is time some sort of RC time constant to reproduce the original intelligence. Okay, so you can imagine for the detector portion, we're just gonna have a diode. We have our amplitude modulated signal, right? Looking something like this. Do my best, right? So our amplitude modulated signal, right? It's also worth noting this is called the envelope, right? And what the detector is going to do is going to clip the top portion, and then we're going to trigger RC, a resistor capacitor time constant, to charge and extract charge at a rate that's equivalent to the peaks and the because if you have the equivalent, if you're able to extract when the peaks are high and have a linear, some sort of linear reaction to the peaks high and the peaks low, you will extract the intelligence. Okay, so that's what's done in a detector. Once that intelligence is extracted, if it's a large enough signal, so when we talk about receiving the detector and the detector gets fed back as an AGC, if it's a large signal, okay, what happens is that the signal here to attenuate will be larger. Okay, if it's a smaller signal, the signal to attenuate will be smaller. Okay, now I believe in my audio lesson I said, well, okay, there will be either you'll attenuate or you'll gain. Well, no, what I meant by that was the fact that one will be attenuating and the other one will be attenuating less. So I referred to it as gain, but that's a mistake. It's actually just attenuate. So this is a normal AGC circuit. Okay. And then from there, once the intelligence extract, all we do is amplify it. And then we impedance match it to our speaker. So if our speaker's 8 ohms, we're going to try to match it to that 8 ohms, or if it's headphones or whatever the case may be. We'll see in the more detailed, we go through a squelch circuit and we also go through a compressor circuit. Okay. Now, when we look at our big guy, we get the KY92 diagram. Now, again, here's I gotta have another video going through each stage here, but here you can see the main players in the actual KY92, right? So you got the low pass filter, the RF amp, the mixer. We have this extra filtration with this crystal filters. We have the first stage IF, second stage IF. Notice that we have AGC injection at the first stage from behind the detector, very much like what we talked about. We'll talk about the squelch, okay, circuit. The squelch circuit, basically, the idea behind that is that if there's no intelligence, we don't want to hear white noise. We want to get rid of it. So the squelch circuit will detect whether the intelligence is there or not. If it's not, it kills any output to the audio amp, so we don't hear anything. Okay, and that can be tuned as well. The squelch levels can be tuned. From there, we go through another low pass filter. Then we go through a compressor, and the idea behind a compressor is just to balance out a signal, right? So making the higher parts, balancing it out with the low parts of the signal. Okay, and then we go to finally our audio amp, and then out to wherever we need to feed it. In a sense, it says this goes to a preamp, and we'll see that when we look at the schematic, the preamp just goes out to our speakers, our headsets, okay, or where else we need to go. Notice that we have also some delayed AGC, which was something we were talking about. The only difference between the delayed AGC and a normal AGC is that what we do is we essentially say, well, if it's a large signal, but that signal has to be a certain level, right? So if it's a really small signal, we just amplify it and we don't do anything as far as attenuate. It has to be a certain potential in order to attenuate, and that's what delayed AGC means. It means it's not going to create any attenuation in any of these stages until the signal's so large that we need to attenuate it, okay? So that's basically the KY92 receiver and AM reception, super heterodyne reception in a nutshell.